In this video, we will use the divergence theorem to evaluate a surface integral. So remember first what the divergence theorem says. It says that for a closed surface S, so this is important, the theorem only applies if the surface is closed. And the surface integral of a vector field over that closed surface is equal to the triple integral over the region E, which is the interior, so it's the three-dimensional region inside the surface, of the scalar function that's given by the divergence of the vector field. So this is what we will use. We will do a triple integral over the region inside rather than do the surface integral itself. So we have to do a couple things. We have to describe the bounds of the integral of the inside of the surface, and we need to compute the divergence of the vector field. So let's do those things. First, let's just compute the divergence, since that is pretty simple. So the divergence of F is the x derivative of the first component plus the y derivative of the second component plus the z derivative of the third component, which in this case is 2x minus 2x plus 3x. So all in all, it's just 3x. And we should describe the region E. So the surface here is the boundary of the region inside the sphere of radius 2 and in the first octant. So the region E, if we draw a sphere of radius 2, is just this part. So the part of the sphere for which all three coordinates are positive. And this is easiest to describe in spherical coordinates. We can describe it as rho goes from 0 to 2, and theta and phi both go from 0 to pi over 2. So we will do this integral in spherical coordinates. So we have rho from 0 to 2, and the other two variables go from 0 to pi over 2. And the function that we're integrating is the divergence, which we calculated to be 3x. So that's 3 times x. In spherical coordinates, x is rho sine phi cosine theta, times, and dv in spherical coordinates is rho squared sine of phi. So this is rho cubed sine squared phi cosine theta. So first, we integrate rho. So we get rho to the fourth over 4 from 0 to 2. 2 to the 4th is 16. 16 over 4 is 4. And 3 times 4 is 12. Okay, next we'll integrate theta. So the integral of cosine is sine and we go from 0 to pi over 2. But sine of pi over 2 is 1, sine of 0 is 0, so all this does is give us a factor of 1. So lastly, we're integrating sine squared of phi, and we use the usual trick. Sine squared is equal to 1/2 1 minus cosine of 2 phi. Integral of 1 will give pi over 2, and the integral of cosine 2 phi is 1/2 sine of 2 phi from 0 to pi over 2. So let's factor out the 1/2. But if you think about it, if we plug in pi over 2, 2 times pi over 2 is pi, sine of pi is 0, sine of 0 is 0, so this whole thing is just 0. And our final answer is then 3 pi.